Hey everybody, welcome to, it's technically our second to last stream of our season here, huh? How is everybody tonight? How is everyone tonight? If you're reading chat, stressed, you know what? I'm a little stressed too, but here's the thing. I just want you to take some deep breaths, okay? They'll all be over soon, and trust in your gut. If you're stressed about this test, or any of the AP exams, just trust in yourself, okay? Just trust in yourself. I've been a reader since 2015, 2016, something like that. Let's go 2016. And the one thing that we've always seen is you do not have to get all the points in order to get a 5, okay? That's simply what it is. You're just trying to get as many points as you can possibly get, all right? So that's all you have to worry about is just try to get as many points as you get. Time management, yeah, but if your teachers have, like in my class, every time we do an FRQ as a portion of a test, they're always timed. Okay, I give them, I don't remember exactly, for a full FRQ, I give them like 22 minutes to write the entire FRQ. So my students are less stressed. Now, hopefully your teachers have been doing something similar. If not, then if you look up back in the chat, let's see who, there's an example of there are the 2 sample questions that were posted. Test yourself on those. I know Harrison has streamed about it last week, Wednesday, they talk about them. I planned on talking a few points about them as well this Wednesday, along with anything else you guys want to discuss. So I'm open to some topics that you guys want to discuss. Let's see what we got here. Tanya used the 10 minutes for the, okay. Good. I'm glad to see you guys are testing yourselves on those questions, okay? Remember, Trevor Packer has said, hey, Kay, Trevor Packer has said that there are more questions in here than you're going to be able to thoroughly answer in the time frame. So if you don't answer everything, that's expected. You were right there with everybody else. You were just trying to get as many points as possible. They put lots of extra things in there so that if you don't know something as well, maybe you can get some other points and still show that you are worthy of, a good grade, okay? Let's see. Feel like I need to be better equipped with the content. Well, that's why you're here, for our content. Of course, we have all of our streams, all of our, replays and all that. They're all available to you. We're working on kind of like a little cheat sheet just to like little keywords to help pop in your brain. It's like, oh yeah, I forgot about that. Okay. So we're working on that right now. It should almost be finished. Okay. So let's talk about what we're doing tonight. Okay. Let's talk about Unit 7, air pollution. Okay. Atmospheric pollution is what we're going to call it. All right. Let's see. So don't forget, we've got a lot of things happening, but we're winding down. These are the 2 weeks of AP exams and all that. Okay, so let me remind you, this week Wednesday is another one of our double weeks. Okay, so I will be streaming Wednesday, talking about FRQ tips and tricks. If you guys got a couple of things that you want me to cover, obviously experimental design is a popular one, so I'm all about talking about that. This stream should be about an hour. Okay. Then on Sunday is our 5-hour review. Okay. We're going to have 2 of our student streamers coming in. Harrison's one of them. They're going to be doing 2-hour review. Then we're going to have an hour of trivia. And then the last 2 hours are me going over everything with you guys. Okay. Anything that you guys have that you want me to discuss, we'll do that. I've got a couple of practice FRQ style questions I want you guys to go through so that we can try to see, where you can get some points on that kind of stuff. Okay. I'm going to do a little bit with that on Wednesday, but a lot more of it on Sunday. And then of course, exam day. Yay. Okay. So that is on Monday, 1 week from today. In fact, by this time in 1 week, you guys will be done with this class and you'll just be kicking back, relaxing. Okay. So let's get into our stream tonight. Okay. Let's get into it. Yes, relaxing, of course. All right. So wait, let me go back. Once again, thank you for being here with us. Okay, you have lots of other things you could be doing, but you're spending your time with me. So 3 more exams after APES. Well, you can relax after those 3 exams. Here's what I'm going to talk about tonight. Okay, so first off, we're going to talk a little bit about sources of air pollution. If you guys did not see my email, then I asked you guys to have this lovely little, let's make sure that's the right file. Yeah, it is. I asked you guys to have that copy, okay? And if you don't have it with you right now, don't worry about it. It's all good, okay? I use that with my students in my class to kind of just as like a cheat sheet as to where certain pollutants come from, okay? Then we're going to talk about photochemical smog and thermal pollution, thermal inversion, air pollution inside your house and inside office buildings. And then the very, very last one on there, we're going to talk about noise pollution, which is kind of a big thing for me. And I'll tell you about that when we get there. But first, let's have you guys look at this. This is going to take a while tonight, okay? So how many of y'all actually did get the email and opened up and got this image? Do we have to connect the... Actually, that's exactly what we're going to do. We're going to draw some lines to connect them, okay? When you're all said and done, let me refocus my screen. When we're all done, it's going to look like this. It's going to look like one of those food webs, food chains. It's just going to have a whole bunch of lines everywhere, okay? Like I said, I do this with my students because it's a fun activity. And it's a lot more fun to just, draw little lines than that, okay? Okay. Hey, if you guys didn't open it, like I said, I just put that link in there. Okay, if you didn't, don't worry about it. You can always go back on the replay and look at it again. Just follow along with us as of right now. So let's talk about, these are the main pollutants up here at the top, okay? NOx is nitrous oxides. So there's NO, NO2. Then there's SOX, SO, SO2. Then there's carbons. We don't say it like that. Lead and mercury, VOCs are volatile organic compounds. What's PM? Do you guys remember what PM is? It does not mean post-meridian, which means nighttime. Particulate matters, exactly. The ones that we usually worry about are the 2.5 and the 1, although you can get up to a 5 too, okay? But 2.5 is pretty good. That's 2.5 nanometers. So that's really super tiny, okay? Very tiny dust. All right, that maybe one that you guys haven't seen before is NMHC. Any guess as to NMHC? Sometimes they're just called HCs. Non-methylated hydrocarbons. Yeah, so if you just don't worry about the MN part, don't worry about that, but hydrocarbons, okay? Hydrocarbons. So basically a whole bunch of, almost like methane, okay? And then CFCs. PM is particulate matter. Usually we look at about 2.5 nanometers. About the size of dust. Okay, sweet. So, CFCs are chlorofluorocarbons. Normally we would talk about that when we discuss ozone because it's big time in ozone depletion, but that's not even on our stuff right now. NMHC, if you just take off the NM, it's just hydrocarbons. The full thing is non-methylated hydrocarbons. Okay? Not a problem. All right. So let's go with our NOx, our nitrous oxides. What are some popular sources of nitrous oxides? Cars are a good one. Yep. I put lead and mercury together because they're very small, small amounts of them in the air, and they have basically the same sources of pollution. Okay, so cars and buses. Here's what I have for you, okay? Bam. The coffee is actually styrofoam. Yeah. So anytime you guys burn stuff, so combustion and cars. So the cars that I have on there basically is burning of fossil fuels themselves. So it's not just cars, but it's like electrical power plants, which I didn't have room on mine right here. The perfume is, is actually a perfume bottle. Oh, next to you have the car, you have the gasoline can, you have the perfume bottle, you have paint, tree, volcano, and fire. Yeah, I thought about not using that one because it looks like a tiny little grenade too. So I left it in there because it was the only one that looked halfway decent like a perfume bottle. So all right, so those are the two main sources of your nitrogen oxides, okay, NO or NO2, is burning of fossil fuels and any form of combustion, okay? All right, so let's look at the next one. We have our SOX, sulfur oxides. Where are you going to get sulfur oxides? Okay, burning of coal, excellent. Okay, we have a vote for the volcano as well. Is the volcano carbon oxides? There are some in that. Yeah. Here's what I got. So, burning of our fossil fuels themselves. It could be gasoline. It could be coal. Again, our volcano. Those right there are very good sources of sulfur. Does a car represent coal? Sometimes a car represents coal. Sometimes it's a car. I messed up and I didn't put the electrical power plant on there, which would have been the coal one. So for right now, we're going to go with any type of fossil fuel. And then the gasoline is more of like a gasoline puddle. If you see it on the street or like at a gas station. Okay. Okay. Next is carbon oxides. So carbon monoxide and carbon dioxide. Now, one thing real quick, this is not one of the main sources of pollution. I mean, this is not an actual pollutant technically because it is very much naturally occurring. So there's a list from the EPA. Carbon dioxide does not make that list because it has a huge natural component to it, okay? So anaerobic decomposition. Ooh, liking the big words, okay? Yes, the gasoline and the cars are separate images. Yep. Okay, so let's look at our carbon oxides right there. So obviously burning of fossil fuels, any form of combustion. Now, why do I have the tree? And yes, the CO or CO2, either one of them. That's what the X is standing are for. That's right. It's a carbon sink. It is, as we saw up there, Skylar had up there, aerobic respiration, okay, and decomposition. So any living organism, you yourself right now are breathing out carbon dioxide, okay? So which one is not being counted? Oh, no, this is for both, okay? So it's either going to be carbon dioxide or carbon monoxide. Any one of them is a source of carbon in the air. Okay, Tanya? I'm eating animal crackers. On the exam, yeah, you can say either one of them. Because carbon is carbon. All right, lead and mercury. Good source of lead or mercury? Oh, no, they can both be counted on there. Paint, yeah. So we try not to use lead paint anymore. Factories, I don't, like I said, I didn't have the factory on here. But yes, factories are a good one. The lead paint, even gasoline, just, obviously we have like unleaded gas, but there are still forms of gasoline which are full of lead, okay? Mercury is also in coal, okay? So where is carbon monoxide actually generated from, though? I thought it was like smoke, not trees. The carbon monoxide is from not fully combusted or not fully actually, burned organic material, okay? That's where you get the carbon monoxide from. When it's fully burned, it actually turns into carbon dioxide. So the trees are not going to produce the carbon monoxide, but the combustion is going to produce both. Oh, yeah, don't get me wrong. Lead paint, Tanya? Yeah, lead paint, much more vibrant colors and everything else. Is more hardy, sticks on the walls better and all that. But it can kill you. All right? We had lots of kids licking. I don't know why they're licking the walls or eating lead paint chips, but that just seems dumb. But yeah, okay. Okay, do the pollutants get generated or just released? So the combustion, anytime there's fire or combustion, they're being generated, then released. With our paint, it's just being released, okay? And the perfume bottle is going to be released. Is anyone taking notes? Everyone takes their own notes. But, of course, we had the replay. The replay will be up tonight. If you need to see it, the replay will be up there tonight. Awesome, Skylar. Okay. Didn't people die because there was a point when people were obsessed with emerald green color, but it had lead in it? There's been a couple of instances like that. Okay, yeah, let's go into VOCs. Yeah, you're right. They are also in paint. That paint smell, perfume bottles, any of these things that have that smell to them, that's a VOC, okay? The reason why I even have trees on there is like if I ever go to Lowe's or Home Depot and I breathe in, I was like, oh, that pine scent. That right there, that's a volatile organic compound, okay? Does the fire represent combustion? Yes, it does. Just my camera so you can see the top of my head. There we go. Okay, so anytime you're smelling something, you're going to get that VOC, okay? That new car smell, stuff like that, okay? Oh, no, a whole bunch of different things are VOCs. Yeah, like if you can smell, well, burning out, if you smell like fresh asphalt, that new car smell, pine scent when you go into a forest, or even, basically almost kind of like that ozone that you smell after a lightning storm, which technically is not a VOC, but all those smells, those are VOCs. Okay, so let's go to particulate matter. Okay, so car fresheners, yeah, car fresheners are VOCs. Can VOCs be deadly? Some people have an allergic reaction to some of them, and as we'll see later, it helps with the formation of smog. All right, so particulate matter. This is a really easy one, okay? A really easy one to remember. Anytime you can see stuff, if you can see smoke and stuff like that, that is particulate matter. They're tiny little particles, kind of like dust and all that. So as you're driving down the road or like a dirt road, all that stuff in the air, that right there is particulate matter. Yes, factories. Again, anytime you can see smoke of any sort, that is a particulate matter. It's a solid that's floating in the air. So even like when you're sitting in your house and you see that little sunbeam coming down and you see those little floaties in the air, those are particulate matter inside your house, okay? All right, hydrocarbons. Again, let's not worry about the NM, but any form of hydrocarbon. Hydrocarbons are all about those gasolines, right? Okay. So they are released from fire, but they originate from the gasoline. Okay. No, don't say or not. But the combustion of these fossil fuels, that's why I brought them to the car and the gasoline. Okay. Technically, if you're burning some biomass, you could release hydrocarbons in the air too. So technically, I should have drawn it to the flames. Okay. Are hydrocarbons flammable? In some cases, yes. The methylated ones are. Methyl groups. All right, last but not least, we have the CFCs, the chlorofluorocarbons, which, again, not technically an air pollutant, but when they get into the upper atmosphere, they really mess up the ozone layer. That comes from styrofoam and the AC of your car. So here, in this case, from the cars, this one is not from burning of fossil fuels. This one is from your AC, your refrigerators. The Freon has forms of chlorofluorocarbons that get released up into the air, and they can mess up the ozone, okay? Should we cross out the, yeah, you can cross out the MN on HCs if you would like to. Just have hydrocarbons. Yes, Sonia. Basically, cars, fossil fuels. Let's not even worry about cars, but fossil fuels themselves are a source of almost all these things on there, okay? Now, don't get me wrong. I can't go anywhere without fossil fuels, but this is the reason why we're talking about this unit, is how we can eliminate some of those problems. Boom. Yeah, you can basically never be wrong when you say the car is a source of pollution. Just make sure you tell them which pollution. The cup is styrofoam. One. The cup is styrofoam. I couldn't find any actual styrofoam images. So yeah, that's styrofoam. The melting and the decay of styrofoam releases the chlorofluorocarbons. All right, let's keep going on here. Let's talk about photochemical smog, okay? This is an image of Paris, and of course, that brown stuff in there is that photochemical smog. In fact, it's actually also known as brown smog, okay? Yeah, the air is so thick you could cut it with a knife. That's what they say about that kind of stuff. So here is the basics of photochemical smog. normally nitrogen dioxide, NO2, and ozone are breaking apart and rebuilding themselves during the daytime and nighttime. So ozone is broken down by nitrogen dioxide, turns it into oxygen, then nitrogen oxide, NO, combines with the extra O, and then they both, like I said, they're going to go back and forth, turning nitrogen dioxide into NO and then NO2, ozone into O2 and then O3. It looks really complicated. Don't worry about it. Okay, here's a really cool thing. This normally happens. So we're constantly putting nitrogen oxides in the air. It breaks down ozone, which is good for us. Ozone reforms, breaks down, reforms, breaks down. Okay. What's the problem is those VOCs. Remember that lovely pine scent that we smell? Those VOCs react and stop NO, nitrogen oxide, from actually breaking down the ozone. So that ozone layer is still, that ozone is still down here with us because the VOCs latched onto it. So now we have this ozone, and the ozone is actually going to combine with photochemical oxidants. So basically things that were created by the light down here next to the surface. Okay. So far, so good? Yes. Hey, you're not being annoying. No, this is the time to ask for questions. Not a problem at all. Volatile organic compound. And we use lots of acronyms, so you don't even have to know what a volatile, an example of a VOC is. You can just say VOC, and you're perfectly fine on that. Okay. Cool. What is the impact of NO2? Okay, so NO2, which is naturally occurring in our atmosphere, breaks down oxygen, turns into ozone, and then that ozone breaks down. I said it wrong earlier. NO2 breaks down oxygen, turns it in and reforms into ozone, and then that ozone breaks down later at night. Okay. So when that happens, that's a natural cycle. But when you introduce VOCs, it stops that that nitrogen oxide from helping to break down the ozone. So now we just have a whole bunch of ozone left in the air that's not being broken down naturally. Okay. Let's see. Kind of like the bodyguards for the ozone. Okay, that works. Think of it more like kidnappers. Don't even worry about my bodyguards. They're more like kidnappers. The VOCs kidnap the nitrous oxides so they cannot, play nice with the ozone and break it back down again. If you want to think of it that way, okay? So here's some of the effects of carbon photochemical smog. I doubt they'll ask you anything about the formation. I think they're going to talk, if they ask anything, they have to ask more about the results, because you can easily just Google how it works. So higher temperatures means that there's going to be more VOCs in the air. Think of like gasoline puddles. They're going to evaporate more, okay? Scents are rapidly being released from like candles. You heat up a candle, then you release more of those scents. So higher temperatures would mean there's going to be more VOCs, okay? Next, since there's more higher temperatures, you're probably going to use more of your AC, okay? So with more AC, you have to have more electricity. Power plants produce nitrogen oxides, okay, because of the burning of coal and other things like that. Also, the more cars you have in the area, the more NOx you're going to put into the air, the more AC you're going to have. So therefore, there's going to be more of this photochemical smog. Again, it's also known as brown smog, okay? All right, so what's the thing that needs to be protected by the bodyguards from the assassins, Osa? I'm not sure. Let's see. What's the thing that needs to be protected by the bodyguards from the assassins? I'm not sure about that. Okay, I'm going to have to come back to that one. Oh, I got a question I didn't pay attention to earlier. My bad. All right, so Ben asked, CFCs being produced in poorer countries still. Actually, yeah, there are some countries that still use CFCs. We've banned them since the 70s in aerosol cans and all that, and it was because of the ozone depletion, but there are still some countries that still use them because it's cheaper than other alternatives. Yeah, sorry I didn't get that question to you earlier, Ben. Okay. Oh, thank you, Tanya, for answering that. Okay. for answering the earlier question. All right, so a little bit more about photochemical smog. Okay, human health problems. It's an eye irritant. Just look at that stuff. It's round in the air. It can really affect your eyes. Part of it is the ozone, and part of it is the photochemical oxidants and all that. So it can irritate your eyes, give it redness, make it scratchy and itchy. If you have respiratory problems, smog is just totally bad to begin with, okay? So it can affect your lungs and give you bronchitis. I have asthma, and it can definitely activate an asthma attack for me, okay? Okay, so aren't most pollutants produced in lower? No, we produce a lot of pollutants around here too, okay? Allergies, yeah. Well, I'm not sure. Allergies mean that you have an allergic reaction to something. So I'm not sure it could possibly cause something and then trigger an allergic reaction to something else, possibly. Here's the thing with the pollutants. We see a lot of pollutants all over the place. Now, the more money you have, the more money you can put into technology to reduce the pollutants. But usually more developed countries have more industries anyway, so it's almost balanced out, okay, for that. Okay, let's continue. Are you guys good with P-Smog? Yep. No, Googling is not cheating. Googling is not cheating. In fact, let me tell you what is cheating. Trevor Packer, actually, I can't tell you what is cheating because they didn't tell us, but Trevor Packer, he's the guy in charge of all AP at College Board. This is what he put out yesterday on Mother's Day. We've just canceled the AP exam registrations for a ring of students who are developing plans to cheat, and we're currently investigating others. It's not worth the risk of having your name reported to college admission offices. Wow, that is powerful. So they did say that anything that can be easily Googled or looked up in like a textbook is not actually going to be on the test, because that's not showing what you know. That's just showing what you can quickly look up. They're looking more of like interactions and like describes, okay? Less of the identified two pollutants you would find in the atmosphere, okay? So, yeah, please, guys, don't cheat. It's really not worth it. I promise you, okay? Not only did they tell the colleges that they're basically sending their scores to, they told their schools it's just not worth it. Cheating's bad, okay? And they're not going to tell us how they're trying to figure these things up because they don't want you to try to get around it. So don't, okay? Even fileable, we're shutting down a whole bunch of stuff so that there's not a chance. You know, temptation is a bad thing, so we don't want to tempt students. So we're shutting down like our Discord server and other forms of talking to each other, okay? Exactly. Crowdcast chats, all of that. Exactly. All right, let's talk about thermal inversion. Okay, to invert means to flip. So that should be a key word right there. We're going to flip the temperatures. Okay, so here's what happens normally. Hey, Sky. Here's what normally happens. You have the warm air that's being heated up at the base of our little column right here because the sun comes down and warms up like the city streets and all that. So we have warm air. Then as you go up, it gets cool and cooler, okay? Yes, Cal, you did ask about this. Hope it was a good answer for it. So if there's like a nice warm breeze, it'll push the air away. So, you know, cities, they have pollution. That's why I have that lovely little, you know, smoke or pollutants in the air right there. If there happens to be a breeze, it'll push the pollutants away, the carbon dioxide, the NOx, the SOx, all those things, particulate matters, okay? But if you happen to be in a valley, it can't push away as easily, but it can still fly up. Now, with a thermal inversion, again, we're going to take the temperatures and we're going to flip them. With a thermal inversion, usually this can happen at night. We have this warm air that's risen up, and the land underneath it has cooled rapidly. So now there's cool air underneath that blanket of warm. So that right there is trapping the cool air, and it can't actually rise because it's cold, okay? So what happens now is those pollutants, those SOx, those NOx, ozones, particulate matters are not able to rise up. And if you're kind of like in a valley, you know, trapped on either side of a mountain, or even, again, if you're on like the windward side of a mountain and wind pushes up against it and you're not able to go anywhere else, then you can have this thermal inversion. And yes, these thermal inversions can cause smog. So there, right there, that right there is a connection between thermal inversion and photochemical smog. You don't need thermal inversions to cause photochemical smog, but if you do happen to have this inversion, it could definitely lead to smog. All right, so I got a question here. Is there any way we can access these slides that you're sharing? Yes, they're going to be in the replays. All those slides are right there in the replay. So once we're done with this night, I'll put a link to the slides right in there for you, and then you can see the replay later tonight. Are there any key places we should know where their thermal inversions happen? Beijing is one of them. Any city that happens to be in a bowl. I believe Mexico City Mexico City does have a lot of smog, but it doesn't have thermal inversions. They're not going to ask for specific cities, but it's the geography. LA kind of in a bowl, and it's being pushed up with there's the ocean right on the side of it. Okay, I got another question here. I don't want to miss this one. How are higher temperatures lead to more VOCs? I did miss that question earlier. More VOCs because when you warm up the air, just like when you're warming up a candle, it releases more of those odor chemicals into the air. So the trees, you can smell trees better on warmer days than you can on colder days. Again, the use of basically your cars and all that can release them too. Okay. All right. So we got that one. All right. Let's go on to the next one. So a breeze has to occur. No. A breeze actually helps to take care of this and helps to move all the pollutants away. Okay. If there's no breeze, then there's no way to move those chemical pollutants in the air. So valleys have a lot more thermal inversions. If you're on one side of the mountain where the wind is pushing up against the mountain, but it doesn't fly up or anywhere, you can see cities right up against the side of a mountain. They could have more thermal inversions as well. Those dark lines in the images, I think of that as the pollutants. That's my little rough. I'm not a great drawer, but those are my pollutants to show that even though they're flying up a little bit, they are not going anywhere. They're being held by that warm air blanket. Okay. Man, I love the chat here, y'all, tonight. It's great. You are helping each other out. This is wonderful. Absolutely in love with you guys participating. Okay, I really do. Okay. All right. Well, you guys good with thermal inversions, or have I missed a question? Yeah, the clouds are the pollutants. Okay. Is the warm air blanket being related to the greenhouse effect? Not necessarily. No, it is not. It's the rough idea of a greenhouse effect because it holds in temperature, but it is not because of the greenhouse effect. It's just a small mini version of it. Okay. Feel like this is because it was on the sample questions. Yeah, it's kind of hard, to think, is it actually going to be there? Because it was in the sample questions. They're not actually going to release. The sample questions are more there for the types of questions they can ask, not necessarily the specifics. So, okay. So it can cause pollution if smog is trapped close to the ground. Yes, most definitely. This will it doesn't cause the pollution; it holds the pollution next to the ground. Okay. So let's continue. Okay, let's talk about indoor air pollutants. I've already talked about one of them, is the particulate matter that you can see in the little sun rays. Okay, so a lot of the people work in like cubicle areas like this or something similar to them, and they can get sick. So that's one of the reasons why we have this whole quarantine, because of the close contact that can happen when you're sick. You can pass on illnesses, but it's not just illnesses. We can have these indoor air pollutants can help hurt people too. So the main ones are like carbon monoxide. So not necessarily an office building, but if you're in a house that this is going to be your underdeveloped areas or your not as developed countries, they're going to burn biomass in order to cook food, okay, or to heat the house. If it's not fully combusted, you have carbon monoxide, which is what we call a silent killer. It can and will kill you by asphyxiation. Basically, you can't get any oxygen to your lungs. You pass out, you die. Okay. Radon is the one that causes lung cancer. In fact, it's the second highest producer of lung cancer in the U.S. It was radon gas. Okay. Should we know asphyxiant? That's just a fancy word for chokes and you can't breathe. Okay. Again, you guys are totally allowed to Google any word so you can figure out what it means during the test. All right. So don't try to worry about memorizing a whole bunch of words. You can quickly just Google the meaning of a word. All right. Okay. Particulate matter, like I said, animal dander, dust, smoke. If your parents smoke, or shoot, even people who vape, that stuff that can produce particulate matter. In older buildings, you have asbestos or mold. Those can get into your lungs and can cause diseases. Asbestos can cause different types of cancer. Okay. Abbreviations are good, yeah. So long as the abbreviations people understand. Okay. Boys' bathrooms have lots of VOCs. Yeah, any place where a boy does his business that has lots of VOCs. Yeah, definitely. They are lung irritants. They're eye irritants. Places that have a lot of Xerox copiers, okay, copy machines. The toner that they use, the process that they use with the toner produces a little bit of ozone, so you can kind of have that tingle in the air that gets into your nose and my eyes. Okay. All right. PM is 2.5 micrometers or 10 micrometers, and your hair is 70. So, which is, yes, definitely. Your hair is way thicker than any of the PMs that we discuss. Okay. Again, particulate matter, you're looking at teeny tiny, you're like literally dust particles. And smaller than that. Okay. All right. Let's see. Am I missing questions? And yeah, you can totally write. Going back to the abbreviation, you can totally write CO. You can totally write CO2. Even NOX and SOX have been accepted in the past. Okay. They're very much cool that you do not have to write the whole thing out. And it's been like that in the past, so you do not have to write everything. Okay, got another question, probably from the last slide. It is from the last slide because I'm not that smart to look. So does thermal inversion have an increased impact on human health? And what would that be? Yeah, the thermal inversion, because it keeps all the pollutants down there. So more allergies, you have more photochemical smog. You're going to have, again, anything that these pollutants can actually cause could hurt you. So a little more eye irritants, lung irritants. When we get to acid rain, you're going to see more occurrences of acid rain in places that have thermal inversions as well, because it keeps that pollution down low next to us instead of spreading it out. Okay. Man, I'm terrible about answering questions tonight. Dadgummit. All right. So VOCs, VOCs, and CO are perfectly fine to use. COX, yeah, so COX, that's either CO or CO2. The X just means it's kind of like a variable. So it's a 1 or a 2. So carbon monoxide or carbon dioxide. Sweet, sweet, sweet. Okay. So one other thing we have to talk about here is real quick. It's called sick building syndrome. Because offices want to spend as little money as possible on like heating and cooling, they seal up the building so that there's very little airflow in and out. By doing that, it traps any of the particles. So if there's no outflow, if there's no outside source of air coming in and out, then any of these pollutants that happen to be in there in the building stay in the building. And you can get what's called sick building syndrome. You get that feeling of nausea, feeling of rundown, get headaches and all that. So literally you are tired of work. It can happen in homes too. Okay, so there's a way to fix this. A whole bunch of plants, or you have filters in your AC and your other central, your central heating and cooling to help filter out some of the particulate matters. There's other like HEPA filters and other things like that are helpful. Why do we get a headache at school? A lot of it's just stress. It may also be bad lighting. My son was getting headaches because he needed glasses, so that was fun. Still gets headaches a little bit, but not nearly as often. But yeah, it's the lighting, it's the constant sound and stuff like that. It may be sick building syndrome, but I know my school was 60 some odd years old, so it's not super sealed. Oh, you get headaches from wearing your glasses. Might be time to look at getting a new prescription. Who knows? As of right now, my eyes were perfectly fine. It's my ears that are terrible. Hang on, we'll talk about the hearing in a minute, okay? Oh, cuts off blood circulation. Heck yeah, it does. Okay, so let's talk about how to reduce air pollutants, okay? So right here, I have a factory, and then, of course, I have that gas nozzle right there. So in order to reduce air pollutants, one really easy one to think about is conservation. Yes, hybrid cars. They use less fossil fuel. So, again, we're looking at... Oh, I got to fix my camera again. I got to fix my camera. That's what I got to do. We're looking at using less fossil fuels, finding other alternatives, even carpooling, stuff like that. Now, I was talking about this vapor recovery nozzle with some of my Facebook friends that teach APES. And some of the ones in Florida have never heard of this. But me and my friend who's down in Houston, us Texas boys, like they're on almost all of our pumps. It's that little, that little gasket, that ring around it. And that is to stop any of the fumes, or to stop a lot of the fumes from escaping out of the car, and keeps it inside the vehicle. And basically that's just gasoline as it is. How many of y'all have seen these vapor recovery nozzles before? Out of curiosity. All right, so the Texas people have, okay. A couple others. Yeah. California has it? Sweet. So it's just the weirdos in Florida. All right, good to know. Who haven't? North Carolina doesn't? Well, we won't say anything about them because I like North Carolina. Okay. You're going to see, it doesn't surprise me that California does. Actually, it wouldn't surprise me if Oregon and Washington State do as well. Again, it doesn't take a lot. It's just a big rubber ring that they put around the gas nozzle to kind of make that seal with the gas tank. Okay. All right, let's keep going here. Let's talk about this catalytic converter. This is required for all of your internal combustion vehicles, so basically cars. And what it does, it takes a lot of these pollutants from combustion of the gasoline and converts them into things that are less bad. Okay. All right, let's see. Never seen in New York. Okay. All right, so it's going to take the carbon monoxide and the NO, basically it's NO, NO2 in your hydrocarbons, and it's going to convert them in again to the things that are slightly less bad for the environment. You're going to look at carbon dioxide, which is better than carbon monoxide. Just atmosphere, it's elemental nitrogen, so just NO, oxygen, and water. You'll notice that you can see like little drips come out of some of the exhaust pipes of cars. That actually is water. Don't drink it. It's nasty, but it's water. And it's because of this catalytic converter. Now, with everything we've talked about, there's always this good thing, bad thing about it. Okay. So what's bad about this? It reduces fuel efficiency by running all these exhaust through the catalytic converter. It slows down the process and it reduces fuel efficiency. So there's a whole bunch of people that, some of my students have talked about it a couple of times. They just remove the catalytic converter. They got an extra, I don't remember how many horsepower and stuff like that from their vehicle. But it's much more dangerous for the environment, okay? Let's see. What would we list all the pollutants and... Why would no? You would not have to list out the pollutants and what they change to. Again, that's something you can easily just Google. So they wouldn't put stuff like that. It's why would you put a catalytic converter into a vehicle? And it's to reduce the amount of emissions from vehicles, which leads to photochemical smog, which leads to acid rain, that kind of stuff. Okay, so yes, we're going to use less. So they pollute less. Exactly. Electrostatic precipitators, catalytic converters, all those fun things we have right here would all be solutions to outdoor air pollutants. Yes, most definitely. They're all solutions for outdoor air pollutants. Indoor air pollutants, you would have to there's certain plants that you can get to pick up certain chemicals from the air, basically allow a little bit of fresh air into the building and some of the old stuffy air out every so often too. Okay. Is everyone getting a different question on the exam? That I have no clue. I really don't. There's been rumors of such, but as of right now, nobody knows. Literally, the very first exams happened today, so no clue if they're doing different versions. Okay. All right. Are we good on this? Are we able to go on to my next topic? Okay. Carbon oxides from all plants, air out the building. Yeah, carbon dioxides. Yeah, but the plant also, takes in the carbon dioxide, which is good too. Okay. All right. So I got no questions. I'm on the ask a question button, so I am good. Let's talk about acid rain. This is one of the easier formulas that you'd ever have to worry about, which itself is not a formula, which is good. So I didn't put a formula on there. Acid rain is also known as acid precipitation, okay? And we call that because you can also have, snow and stuff like that, or particulate matters. All right, so anthropogenic sources. So again, that anthropogenic is a fancy word of saying human sources of these pollutants. Cars, factories, electrical power plants. Basically what it is Sonia has in there, is NOx and SOX. Ozone, yeah, there is some ozone. Okay, ozone could play a part, but the biggest sources of your acid rain is going to be your NOx and your SOX. Okay, so you're going to knock your SOX off. Those are the biggest ones. And what happens, primary pollutant, which means they are the first forms of a pollutant. Okay? Who froze? I froze? No, I don't want to freeze. Well, I do, but I don't. I want to move somewhere there's nicer temperatures year round. All right, I'm back. Cool. All right, so what was the last part you guys heard? What do I need to back up to? Knock my socks off? Okay. So, yeah. Acid rain will knock your socks off. It does have a little bit to do with ozone, but it's really nothing. It's not a major source of this acid rain. So, all those items that we talked about earlier on our drawing, all these little ones at the top, the NOx, the SOx, the carbons, and all that, those are what we call primary pollutants. Okay? I'll explain it here in a moment. Those are our primary pollutants. When they are altered into something else, then we consider them a secondary pollutant. So primaries come directly from the source. Secondaries are altered to something else. Okay. Yes, NOx are nitrogen oxides. SOx are the sulfur oxides. And the reason why I say acid rain knocks your socks off is because most acid rain is from NOx and SOx. Okay. So the NOx and SOx in this case are the primary pollutants. They come directly from cars and burning stuff. When they get into the atmosphere, they will combine with the water in the atmosphere, and then they produce acids like sulfuric acid, nitric acid. Okay, and then those things fall down as secondary pollutants. So NOx and SOx go up as primary. They combine with water and fall down as secondary. We good so far? Does that make sense? I'm trying to read chat here. Okay, so far we're good. Okay. So again, they're probably not going to, man, I've got to get better cameras. So they're probably, again, not going to ask you about how the formation of it works unless they say, what are some major sources? Again, factories, burning of fossil fuels. What I would see them asking about is the ecological effects. So a precipitate, basically, it can come down as solid materials instead of just as water. It can come down as flakes, kind of look like sky dandruff. Yeah, so if it alters with the water in the atmosphere, but it doesn't actually become wet, it can come down as dry precipitation, or like I said, yeah, almost like ash, exactly. All right, so ecological effects. So acidic rain, acidic precipitation, it can leach minerals and nutrients out of the soil. When that happens, that hurts the plants. Remember, they need some of those nutrients in the soil in order for them to grow. Aquatic organisms, they have a limited range of acid that they're able to survive in, a limited pH range. So when we put a lot of acid into lakes and streams, then that lowers the pH, making it more acidic, and that can really affect their ability to live. It can easily affect their lungs. It can affect their not lungs, their gills, their eyes, even some of their scales too. Okay. Less pH. Yeah. So remember, on a scale of 14 down to 1, 7 is the middle. 14 is very basic. 1 is very acidic. And 7 is neutral. So as you go down, you become more and more acid. As you go high, you get more and more base. Okay. Higher the number, the more basic. The lower the number, more acidic. All right. Also, when acid precipitation falls on plant leaves, it causes spots on them, and those leaves cannot perform photosynthesis nearly as well. So a lot of people will notice that, again, it's from like factories and electrical power plants. Those are not the places that are being affected by the acid rain. The winds that we talked about earlier, they're those like major air currents and all that, they will take these primary pollutants, the NOx and the SOx, and they'll carry them downwind and to other communities and all that. So the places that produce these primary pollutants don't see the effects of acid rain. It's downwind from them that get these acid rain effects, like, again, leaching of nutrients from soils and stuff like that. Okay, does that make sense? Acid rain is basically bad for everyone and everything by out. Basically, yeah. If you get acid rain on yourself, it's unless it's like, sci-fi movie acid rain, it's really not going to burn you. It might discolor, have teeny tiny little spots on your shirts. That's about it. A rash, maybe if you're like really, it'd have to be really strong acidic rain to have a rash. But even in some cases, if your skin's sensitive to it, it's a possibility. Yeah, plants are more sensitive to it than humans are. Okay. Well, welcome back, Jacob. He has a question. Doesn't acid rain also make aluminum more soluble? Yes. One of those, it's not only about leaching of materials out of the soil, but yeah, there are some like metals like aluminum that are locked up in they're like basically in rocks, and this acidic rain could put them into the soil and allow them to be more acidic as well. Excellent there, Jacob. Cool. All right. So my last part tonight is noise pollution. Like I said, this one is a little bit special to me, and let me tell you why. Take it out of my ear. I wear one of these. I wear a hearing aid, and it's not because I listen to loud music. I'm too old for that. It's because, dang, my silly camera. Oh, that's right. Thinking about that. Yeah, so I wear this lovely little hearing aid right here. Noise pollution? No, actually. So in this case, I'm very sensitive to noise pollution now, but some of the bones in my middle ear, they are fused to my skull, meaning I can't hear very well without this. So, again, noise pollution is a big thing. I do not like it when my students are walking around with their earbuds and I can hear the music like 10 feet away. It's just absolutely terrible. My son is percussionist in the band. I'm constantly telling him, please put your earplugs in. Please, please, please. Okay? It's very important to protect your hearing. Very, very important. Okay? And it's for a couple of reasons. Okay? Let me put it on here real quick. One, you don't get your hearing back. Any loss is gone permanently. Absolutely permanently. So what exactly is noise pollution? Noise pollution is any volume that causes stress or possible hearing loss, and it doesn't take much and it doesn't take a long time to cause hearing loss. Okay, hearing loss obviously is not recoverable. You're never going to get back your hearing. My hearing aid is the only way I can actually hear out of my left ear. Without it, everything is a very, very soft whisper. Okay. Yes, earbuds are very harmful in your ears because people usually turn up their music too loud with earbuds in, trying to block out everything that's happening around them, and they don't realize that. I only know the sign language that I'm not allowed to show you on screen. That's the only sign language I know, unfortunately. Good question, though. Terrible example as a teacher, but yes, that's a good question there. Could machines used in mining? Yeah, any loud machinery, construction, mining, stuff like that. I heard a car race down my street, and then I could hear it about a quarter mile away racing up another street. Loud cars, people. It's not all about that bass. You can turn your music down. Galveston, when I was younger as a teenager, instituted a noise ordinance. You are not allowed to, on Galveston Beach, have your cars so loud that people outside the vehicle could hear it. And you could get a massive ticket or fine for it. Okay. Oh, I got another question. I probably missed it earlier. So is there a largest contributor to noise pollution, specifically in the U.S.? Specifically in the U.S., no. Any one of those. Construction. So big cities are going to have lots of construction. You'll see the construction workers are wearing earbuds. Rifle ranges, you're going to have earbuds as well. You're going to have, not the earbuds, but the earplugs. The other part of the question is, what is the level at which stress or hearing loss occurs? That's actually a question for my wife. Wife, are you here? She is not here.
Talking to me?
Yes. What is the decibel level that starts to cause hearing loss?
60.
60 decibels. Okay. Hi, Samantha. 60 decibels. That's not much. Actually, my voice is hitting by about 50, 55 right now. So a hair dryer is right about 60, a little bit higher than that. Okay. So anything higher than that, you can start having hearing loss. I believe at 90 decibels for 15 minutes, that right there is permanent hearing loss. Okay. A rock concert. Yeah. Rock concerts at 120 decibels. I like listening to live music, which is great, but I like to keep my hearing. So I actually have to, I have a special earplug in order to take care of that. So I cannot have too much damage. It muffles it, but dang it, it's still nice. A TV at 100 volume, Tanya, I think you're already experiencing hearing. As it is right now, y'all have already experienced hearing loss in your life. Your hearing, as you get older, decreases. Okay. Way, way faster as you get older, though. All right, so let's see what else is on my slide right here. So how does this going to affect like life? What kind of stress are we looking at? Okay, so we know why it happens, but what else is stress? Okay, so noise pollution can affect animals. It can affect their ability to mate. That's why you see those lovely little happy little frogs down there. It can affect their mating patterns, like the frog sounds, the bird songs, echolocation of bats. Yes, the sonar of your killer whales too. Yes, okay. So the call of the blue whale, you say, reaches up to 188 decibels. It is muffled by the water, and it also has to spread out. Is that a cup? That's a bouquet of flowers that the frog is handing to the other girl frog right there. Is he trying to propose? Let's just say yes. Let's pretend it could be a cupcake, but yeah, whatever. Well, exactly, a sonar. It is basically echolocation underwater, sending out a noise, and as it bounces off of things, timing how long it takes to get back to you. That's sonar. Okay. So again, of all of our, air pollutants, this is the only one that doesn't actually have a physical or a chemical thing. This is just pure sound. Yeah, dolphins are going to use sonar. Bats use echolocation. Yeah, so sonar is underwater. Is sonar machines? No. Those you can still consider like what the dolphins do sonar. Yeah. It's still a form of echolocation. Sonar itself is an acronym, but as readers, we're not really worried if you know the difference between sonar and echolocation underwater. Is it possible for all of us to link our notes in this chat to cross-reference in case we miss anything? It's possible. What I wouldn't do is have that available during the AP exam. That right there, again, sharing of information between people, that right there is one of the things that they consider to be cheating. Okay. Again, if you guys don't like your notes, please go back, watch the replay. Okay. That I love replays. I like the idea of being able to stop, write things down, let it process in my brain, that kind of stuff. Okay. So that is my end tonight. Okay. Daggum, Jacob, 43 page. Daggum. That's a lot of notes there, buddy. Okay. The cram final will be student-led. The first half is going to be student-led, and then we'll have trivia game, and then the last 2 hours is me. Yeah. So I think it starts at 3 o'clock this Sunday, 3 o'clock Eastern. So 3 to 5 o'clock, it's going to be led by our student streamers, Harrison being one of them. Then we're going to have some of our trivia. It's not going to be Kahoot. It's going to be our trivia that we play here. Although I was asked, maybe I can find like some Kahoot games, kind of like review games, to put that out there. You know, I'll put that in the email. You know, just, you know, fun little things. Okay. Thought about doing that. Let's see what other questions are going on here. Oh, yeah. And then the last 2 hours will be me going over stuff. So I'm finishing up what I want to do with y'all on Wednesday. Okay. I thought about talking about the experimental design. I know Harrison did it last week. I don't want to step on his toes. He did a good job. But if you guys want, I want to talk about those released questions that College Board put out. Little things about that. I want to talk about little things that I've gathered as being a reader, things that you should not worry about, things that you shouldn't do. Okay. You guys want me to go over those CB questions? All righty, I'll do that. Yeah, it's the same bat time, same bat channel. Okay. It's this Wednesday. Not a problem. I'm all about it. Also, don't forget, did you guys watch last week's? Yes, it's this Wednesday. Did you guys watch last week's stream with the NIMSY people? One of my friends, Matt Wells, was doing that one. They went through a lot of good things too. Everything they said, I was going to basically do this Wednesday, but since they already did it, I'm not going to redo the whole thing. There's a couple of things that I want to talk about. Okay, it should be on a replay there. Should be a replay somewhere. So this Wednesday one is our second stream this week. Our second cram stream. It's just about FRQ tips and tricks. Okay. FRQ tips and tricks. That's what I'm going to go over. I'm going to open up that link to see what y'all looking at here. Boop-a-doop-a-doo. AP Environmental Science, a review of the timed AP exam practice number 1. Sweet. So they went over it too, as they should. Okay, cool. You're doing a Q&A at 1? Awesome. Oh, yeah, that's right. Don't forget. There is a Q&A, question and answer. It's at 1. Is that 1 Eastern or 1 Central on Wednesday? Mountain time. Okay, cool. So 1 Mountain time. That makes it 2 Central and 3 Eastern. Okay, sweet. Yeah, so if you guys have more questions and answers, go to that one right there. Okay, go to that. If you're able to make it, that would be great. Okay, is there any way that you guys can contact each other after the streams, like in an hour or so? I guess if you guys share with your email addresses right now, you can do that. Round of the day, that's going to be Wednesday. Yeah. Okay. All righty. Do y'all have any other questions for me? Oh, yeah, sure. You guys, Instagram, you guys can talk over like that. That works too. Just not during the test. Don't do it during the test. All right. Yeah, definitely not during the test. Okay. All righty. Well, I appreciate y'all being here. again, I'll get this stream uploaded here in just a couple of hours once we finish downloading. Okay, and I look forward to seeing you guys on Wednesday. Please go to that Q&A on Wednesday afternoon too. That'd be great. Of course, if ever you guys need something, email me. Okay, I try to get back to you as quickly as I possibly can. I want to try to help you as much as I can. I feel like I'm your other teacher. I'm not your real teacher. I'm just your other teacher. I'm like your substitute, but with a really awesome beard. Okay. So, ladies and gentlemen, I hope you guys have a great, wonderful rest of your day. I'll see you hopefully in about 2 days on our almost last stream of the season. Okay. So, ladies and gentlemen, ta-ta, see you later, and have a great night.